Assalamu alaikum. So in this video, we'll see section 3.2 of calculus course about the derivative as a function. So we'll skip the first parts because in these parts you will later use the definition to define the derivative, and in next sessions you will see a much easier way to do it. So no need to lose time on these parts. But here what's interesting is to see graphically when does a function not have a derivative at the point, and the relation between differentiable functions, so function which have a derivative, and a continuous function. So we'll focus on these 2 points, inshallah. Then these definitions شفناها already for derivative at a point and replacing x0 by x using the same steps in the previous video, and you will find the derivative of any function x. But of course, as I said, in section 3 you will have formula for the basic function. You will use directly the formula instead of the definition based on the limit. Just a point which is important, how to denote derivative. We can use all this notation for a derivative. You can denote it as f prime of x, or y prime, or dy over dx, to say that we derive with respect to the variable x of the equation y, or df over dx, to say that we derive the function f with respect to the variable x. So this notation is used mainly when we have several variables, so to denote to which variable we are deriving. We can also use the derivative of f of the variable x, or the derivative with respect to x of the function f. So all this notation can be used to denote the derivative function. Now, as I said, I want to focus more on this slide and next slides. Given the graph of a function, when can we say that this function has a derivative at a point, or it doesn't have the derivative at a point? So a function doesn't have a derivative at a point, for example, in this case, when we have a corner, okay? When we have a corner, for example, if we draw the graph of the function absolute value of x, LV, okay, this is f of x equal absolute value of x, we see that at 0 we have a sharp corner here, okay, زاوية, okay, and in this case the function doesn't have a derivative at 0. The reason is easy, because here the tangent to the left at 0 minus the slope of the tangent. شوفوا tangent هنا السلوب متاعها negative equal -1, whereas here the slope is positive and equals 1. Okay, so the slope to the left and the slope to the right are different. So دايما when we have a sharp corner, the function doesn't have a derivative at this point. تفرق مثلا إذا كانت عندنا x square ما عندها smooth, okay, smooth function, ما عندنا sharp corner like this, okay. So هذه it is The derivative exists everywhere and especially in zero. Okay. لأنه هنا تمر من slope سالب لكن هنا عندنا horizontal tangent فسلوب زيرو وبعدين تروح slope positive. Okay. So هنا the function has a derivative at zero and is differentiable everywhere. هنا لا. It doesn't have a derivative at zero. Another example where we have problems of derivability is, let, for example, consider this graph. This is the function cubic root of x. اللي هي the inverse function of the cube function. Okay. اللي هي x to the power 1 over 3. نشوف the slope of the derivative at zero. هنا to the right the slope. So the tangent is a vertical line. خط هذا العمودي and the slope is infinite. هنا the slope is minus infinite. Okay. So in this case also the slope is infinite and the function does not have a derivative at this point. Okay. Even, for example, for the function root x. The function root x الجذر التربيعي يجي كده الفانكشن root x. So هنا the slope of the tangent line at zero is infinite. The tangent line is the vertical line. Okay. وهذه ممكن نشوفها حتى لما نحسب الديريفاتيف. So f of x هي x half. شفتوا انه الديريفاتيف اذا عندك g هي the power function g prime هي n x n minus 1. إذا هنا the derivative راح تكون half x minus half. Okay. or 1 over 2 root x. إذا نشوف هنا إنه الإكس في المقام صار. فإذا تحط 0 1 over 0 is not definite. No division by 0. Okay. So f prime of 0 doesn't exist. Okay. ممكن نشوفها من الجراف لأنه عندنا the slope of the tangent at 0 is infinite. So we have a vertical tangent. Of course, definitely when the function is discontinuous, so it's clear we cannot talk about derivability or differentiability. If it is discontinuous at the point, it is not differentiable at this point. Okay. إذن هذا أيضا نفس الشيء قلنا تيجي كده وتمشي كده فهنا the tangent is vertical line عندنا sharp cusp sharp corner ف it's not differentiable. إذن هذم حالات وين من الجراف نقدر نقول هل our function is differentiable or not. اللي نقدر نقوله what we are sure about it is that if f has a derivative at point x equals c, we are sure that it is continuous at this point. العكس إنه if f is discontinuous at x equals c, we are sure that then f doesn't have a derivative at x equals c. Then خلينا نشوف مثال. So in this example, we have the graph of 4 different functions. السؤال, for each graph, we have to say where the function is differentiable, where it is continuous but it's not differentiable, and where in which points it's neither continuous nor differentiable. So we start with the first graph. So here it's a linear function. So as you see, we have no problem here. So for this graph, the function f is differentiable over its domain اللي هو من -3 حتى 2 closed. Okay, so this is the domain, no problem. In which point it is continuous but not differentiable, ما فيه. In which point it's not continuous and not differentiable, ما فيه. نفس ملاحظة على this second graph. So هنا f, so it's smooth. So here it's smooth. We have no sharp corners. Okay. فهنا أيضا ما عندنا مشكلة. So f is differentiable everywhere on its domain for x greater than or equal -2 less than or equal 3. شوفوا المثال الثالث. إذا هنا وين عندنا مشكلة؟ عندنا مشكلة في الزيرو. في الزيرو it's clear it's not continuous at zero. So it's not continuous at zero. It cannot be differentiable at this point. Okay. So هنا for this third example, and f is differentiable when for x greater than or equal -3 less than 0 and x greater than 0 less than or equal 3. لأن عندنا المشكلة هنا في البوينت 3. when continuous but not differentiable ما فيه. وأخيرا when it's not continuous, where is it not continuous ولا differentiable? at x equal 0. At x equals 0, we see that f of 0 is 0, but the limit at 0 to the left of f of x is 1, 2, 2.5, or it's not 0. It's clear that it's not 0. Okay, so here we have clear discontinuity. The interesting case is the fourth graph. So we have discontinuity here at 3. We have discontinuity here at 2. But we have also a corner here at 1. Okay, so here f is differentiable for x greater than equal -2 less 1 and for x greater than 1 less than 0. At 0 also we have problem. At -1 هنا, sorry. So we have a problem at -1, a problem at 0, and a problem at 2. And x between 0 and 2, and finally for x between 2 and 3. Where is it continuous but not differentiable? At x equal -1. It is continuous, مستمرة, but we have a sharp corner. It's not differentiable at this point. Where it is neither continuous nor differentiable, at x equals 0 and at x equals 2. So this is how we read continuity and differentiability at from the graph. I repeat, differentiable معناها has a derivative, هذه هي.